Good day everyone. Today I'm going to discuss about number systems and data representations. So at the end of the discussion, you'll be able to understand the number systems, why we need to convert those number systems, as well as the importance and the different or the common number systems. We have the decimal, binary, octal, and hexadecimal number systems. So first, let us discuss on the number system. Suppose I'm going to give you a number. We have 1, 2, 3, 4, and 5. So you are actually familiar with this, right? When I say also 1 plus 2, based from the computation, that is equals to 3. And when I say 10 minus 5, so from the computation, that is equals to 5. So we can actually understand this because ito yung ginagamit natin in our day-to-day activities. And this type of number system, ito rin yung default number system na yun nga ginagamit natin. So in a computer system, each of the values or any informations that are saved on the computer, meron siyang corresponding na number equivalent. And the question is, anong klaseng number system ang ginagamit ng computer? So let us try to discuss that later. So ang number systems, they are the technique to represent numbers in the computer system architecture. So yun nga, every value that you are saving or getting into from computer memory has a defined number system. So ibig sabihin, for example, mag-type ka ng letter A. Ang letter A, meron siyang corresponding na number equivalent sa computer. So kaya siya merong equivalent na number in the computer system. It is because a computer can only understand number. Okay, so as computer architecture supports different number systems, so we need to study them and also need to know the conversion technique between them, especially sa inyo that you are in the computing industry, no, sa mga IT, ISCS, mga computer engineering. So ito yung mga basic na kailangan nating ma-understand. Now, so long ago, humans looked at their hands, saw 10 fingers, and decided to use a base 10 system. Okay, so ano yung base 10 system? Ito yung decimal number system. So kaya pala decimal number system, because of this, no, we have 10 hands, 10 fingers rather. So that is why we decided to use base 10 system. Now the question is, how many fingers does a computer have? So let's try to find out. Okay, so in a computer, of course, it needs to run in an electric current, right? So ang electric current, meron siyang dalawang states. So they have also two different voltage. Meron tayong high voltage and low voltage. So sa computer system, ang high voltage, that can be represented by 1. Ang low voltage naman can be represented by 0. Another, computers are built from transistors, and an individual transistors can only be on or off. So meron siyang dalawang options, on at saka off. Okay, sa data storage devices, meron tayong optical or magnetic. Sa optical storage, data in a specific locations, controlling whether light is reflected off that location or is not reflected off that locations. So ang storing of data sa optical storage, meron pa rin siyang dalawang options. Okay, how about sa magnetic? Okay, sa magnetic naman, devices store data in a specific location by magnetizing the particles in that location with a specific orientation. So we can have the north magnetic pole pointing in one direction or the opposite directions. So dalawang options pa rin siya sa magnetic storage. So yan nga, sa opposite directions, one's position in a relation to true north, to points on the compass, or to a specific place or object. Ayun. So as we can observe, no, So most of the activities that the computer did or do, or most of the functions, were actually has two options. So that is why ang computer system is actually represented in binary. So meaning to say, lahat ng mga data or information na nakastore sa computer, they are represented in a binary number system form. So such as your movies, your applications, the informations on the internet, or even your data in your social media. So lahat yun, meron siyang representations in binary. So from this, we can actually say that the language of computer is a binary number system. So ano ba yung binary number system? Ang binary number system, meron siyang dalawang the two digits in each position. So dalawa lamang siya. So merong 0 at saka 1. So that is why most of the mga caricature na makikita ninyo that would actually represent the language of computers is represented by 1 and zeros. So when we go back to our history of computing, so if you can actually remember, so yung gumawa ng punch card, si Jack Portloom. So yung invention niya na punch card that is actually used on the computers before. So meron tayong a paper tape, no? A tape reader would be used to input binary just to represent A. So ito yung binary form niya, 100001 just to represent A. So ito yung parang ganito yung yung punch card. So meron siyang holes, no? May mga butas-butas siya. And then yung mga butas na yon, pag meron siyang butas, that is equals to 1. Pag wala, that is equals to 0. So ganun yung representation niya. Okay. So to make programming easy, a layer of abstraction was added on top of binary. So example, itong binary number, and the result software was what we know as an assembler. So since ang computer can only understand a number, specifically the binary number system, which is also referred to as the machine language or the machine code, no? So hindi natin to maintindihan. So it is difficult for us to understand this. That is why humans develop an assembler. So ang assembler, ito yung nagtra-translate, no, from your binary code or machine code into another language that the programmers can easily understand. So we have here, sa illustration, meron tayong assembly, no? So from assembly, so that will be then translated by the assembler into a machine code. So by then, once na ma-translate na siya, then now the computer can understand it already. So assembly language, medyo malapit pa rin siya sa machine code. So medyo mahirap pa rin to. Then actually we will be discussing this sa other subject ninyo sa computer architecture, assembly language. So meron din tayong tinatawag na high level language. Yun na yung mga C++, Java, Python, and any other na high level programming languages. So yun yung mga programming languages that most of the programmers has been using. So medyo easier na siya sa atin to manipulate the codes, no? It's because hindi siya naka-machine code. So from those high-level programming language, it will be translated into a machine code para ma-understand na ang computer. Okay. So the PDP-11 computer made by the Digital Equipment Corporation used the octal numeric system exclusively for displaying memory addresses and content. So before, ang computer architecture, we're using the octal numeric system, no? So that is base 8. But since nag-upgrade na siya today, so nineglect na nila yung octal, so they are now using the hexadecimal. So that is why CPUs converted to bit sizes of 32 and 64 bit. So before 26 and 36 bit. Now sa computer architecture 32 and 64 bit na, and they are no longer utilizing the octal decimal number system. Instead, they are using the hexadecimal number system. Okay, so bakit hexadecimal number system ang ginamit nila? So, instead of other number system. So, for example, we have here a 16-bit binary number. Ito. So, ilang digits siya? So, we have 1, 2, 3, 4, 5, 6, 7, 8. So, marami. More than 10 digits. Whereas, if you are using a hexadecimal form of this number, 4 lang siya na digits, which is also more readable and very easy. So that is why some of the modern computers are now using the hexadecimal than of any other number system. Okay, so furthermore, using the hexadecimals, no, it is also used in memory locations and addresses. Isa din to sa uses ng hexadecimal. Okay, so it can characterize every byte as 2 hexadecimal digits only compared to 8 digits when using binary. So, ibig sabihin, kung binary yung gagamitin natin, it can consume 8 digits. Whereas, kung hexadecimal, 2 digits lang ang mako-consume. So, that is why sa memory locations and addresses, they are using hexadecimals. Still, we have to understand the binary. Kasi, yun nga, from the hexadecimal, it will be translated to binary in order for the computer to understand. Okay, so, moreover, the uses of hexadecimal, it define colors on web pages. If you are already had a background sa HTML, so kung ma-observe ninyo, ang colors in HTML are represented by this. We have RR, GG, and BB. So RR, red, GG, this is for green, and BB, this is for blue. So 2 digits for each color. So meaning to say, 2 hexadecimal digits for each color. So that is why yung okay, so yung black can be represented by 0, 0, 0, 0, 0, 0. So 6 na zeros, at yung white naman can be represented in F, 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 F. So 6 rin na F. Okay. So yan yung representation ng colors in web pages. They are using hexadecimal. As well as in displaying error messages. So hexadecimal din yung ginagamit nila. No? They are using it to define the memory location of the error. So very useful for programmers in finding and fixing errors. Okay, so another uses of hexadecimal, it represent media access control, or yung tinatawag natin ng MAC addresses in your computer. No? So the first 6 digits of the MAC address represents the ID of the adapter manufacturer, while the last 6 digits represents the serial number of the adapter. Ayun. So, kaya if meron kayong encounter na MAC addresses, it is actually represented in a hexadecimal number system. Okay. So, yun yung part 1 ng number system and data representations natin. So, for this discussion, you learn about the number systems, decimal, binary, octal, and hexadecimal, and also understand how computer works with those number systems. And of course, you learn about the octal and hexadecimal usage in computer systems, as well as our default number systems, which is the decimal number systems. Okay, so for your learning activity, you are just going to answer this. What are the uses or importance of each number systems in computer systems? So that includes the decimal, binary, octal, and hexadecimal. So that ends for your part 1, and for the next discussion, it is about the number system conversion. Good day.